Hey YouTube, it's me Rosin. I'm here to give you a talk I gave a couple of years ago at the jsTalks conference. It's about how we grew the project, what are the challenges that we faced and how we tackled them. It's about the front-end side of the project. I think the topics are pretty much evergreen and applicable today, so let's jump right into it. Picture this, imagine starting on a brand new project. It's a blank canvas. There is no legacy code, there's no one to blame. It's up to you and your team to build this state-of-the-art application. As months go by and new members join the team, they can help themselves but just stop every few minutes and admire what you've created. Unfortunately, this is not the result most of the time. So let me walk through the challenges we had, how we solved them, and hopefully for you it will be this way. A quick disclaimer, this is not a step-by-step guide on how to create an application and scale it. I'm just sharing some insights. I will be using the project timeline as a framework, and I'll highlight key decisions that we made, some milestones, how the team grew, and the challenges we faced, as I already said. And the first big decision that we had to make is choosing the framework for the front end, or shall we even use a framework? I will not spend too much time on this controversial topic. There is an article that I wrote about this whole talk, and you can find it in the description. There is more detail to that decision. Here I'll quickly sum up that we needed the framework to be suitable for everyone to join in and contribute. This means also backend developers, and also we needed something that is pretty reliable. And I think Angular learned the lesson with AngularJS, and every change they introduced was pretty much not breaking. So I'd say that was a pretty proper decision. And one more word about front-end frameworks. They're just a tool. Find out what your business needs, what best suits the team, and go with it, and don't worry about what's the most hip, fancy new thing. Once we had that, we started producing code, the team grew. I joined around that period, and we had to choose a testing framework. And with Angular, there are some built-in options like Karma, and Jest is pretty much very easy to replace Karma if you want to. So we decided to go with Jest. The key benefits here for us are that Jest runs in the command line and it uses JSDOM. We didn't at that time build a component library, so for us the benefits of running the tests in the browser were not very obvious. Also, when I get to the part where I talk about how we structured our project, you'll see how that decision benefited us there too. But if you are building some UI heavy stuff, I think with Karma is also viable too if you want to test in the browser and debug there. But for us, that wasn't the case. One more word on tests. We decided to forgo end-to-end tests as the project was developing quickly. We were changing requirements, layout, and so on. So end-to-end tests would break more often than not. So we decided to stick to unit tests, but to be diligent and have a good test coverage. Okay, we continued growing. We were about 11 developers at that time. We had to introduce a new project into our repository, so we had to think of a project structure or a repository strategy. So first we decided in favor of time to move with one shared library, and everything that needs to be shared between the new project and the old one goes in the library. There are no issues with that approach whatsoever if you think about it. Okay, And also we decided to use NX as a tool to help us develop things. So NX comes with some really cool features like enforcing boundary rules, so you can define different projects or libraries, define different types, and how which can depend on which other. For example, no project can depend on each other, libraries cannot import things from projects, and so on. Also other cool features that I'll talk about a bit later. Unfortunately, with that approach, having a single shared library, it became pretty convenient for the developers to, when writing tests and doing the setup, to include the whole library instead of just what's used in the test, and that quickly became a problem. As you can see down there from the results of the tests, the shared library became a place for everything shared. So when you include it, you include a whole lot of things that you don't need in the test. And these components, services, they take time to initialize. So key takeaways here, keep an eye on the tests frequently, because when the execution time becomes a problem, I think that's pretty much too late for you to start optimizing. Anyways, there is no such thing as too late, but yeah, keep a regular eye on tests and also keep an eye on what you're importing in the tests. Okay, we continued growing. Now we were 15 developers, we were 3 teams, we had to add yet another project. So this single library approach, though convenient at first, became a little bit of a problem, because now when only 2 of the projects need to share a thing, for example a component, it goes in the shared library, and the third project imports it although it doesn't need it. And yeah, tree shaking may work, but still it becomes difficult to know which components are used where, which components are supposed to be reused, which are there just for convenience purposes. So we decided to go with another approach. Have one library for common things and other libraries for sharing components, services, utils, etc. between projects. But still, as I said, there were some challenges with this approach too. So we actually needed to sit down and rethink our whole library strategy. All members of the team have previously worked with a library per component approach, and we started evaluating it first. We all didn't like it that much, because although there are benefits to it, for example, it's easy to maintain because every component is isolated, it's easy to customize, there are versioning and so on. However, there are a lot of overhead that comes with that approach. It becomes difficult to manage, especially if the components are in a different repo. And at the end of the day, what we noticed is that pretty much when there is a new version of the component, every consumer needed it. So this whole versioning thing was just a big overhead. Another approach that we evaluated was the domain-driven design approach. We already use that in a couple of places of our backend, so we decided why not take a look at it at the front end. However, what we feared is that, yet again, because on the front end we didn't have such clear separation between the different domain contexts, we didn't have clearly defined boundaries, it would become too cumbersome to comply to the DDD approach, and oftentimes we would force ourselves to do things in a certain way just to comply. So we looked further, and of course, using the NX repository, they have a guideline for how to separate libraries, and it's pretty straightforward. The approach here is to organize them by context. For example, UR libraries where you have only the DOM components or the presentational components stay in one place. The data access is separated in a separate library where you may also include some state management, and utility libraries are for common utility functions. Feature libraries for us was kind of the perfect mix between the DDD approach and the NNX approach, because it allowed us to have these clearly defined, full-fledged features that are completely developed. They could be separated, they could have clear boundaries and bounded context, and we can really use them, basically drop in place and just start using them in the different applications. But whenever we could not stick to that approach, we would use the other libraries to extract the things that we can reuse, and then every project would build its own thing. Okay, what are the key takeaways? I'd say think of a library strategy as soon as you create one, because the strategy affects all parts of your application: builds, imports, tests. Yeah, I wanted to share one cool feature in NX. You have that thing called affected, and you can build, test only affected parts of your application. This means that if you have let's say a tree of dependencies of libraries, and one of the leaves is changed, the affected CLI function goes through the graph and only selects the nodes that are affected, or the libraries that are affected, and builds just those. And nowadays we use it to improve the performance of our tests. For example, we spawn new CLI job for each affected library, and this way we can do them in parallel. Okay, let's move on. We continued growing. Now we were 22 developers. We had some features ready to be tested, and that's what we did. We wanted to verify our assumptions, and the results would guide us how to give priority to upcoming features and how to continue forward. And we didn't have to wait long before some surprises came from that test. For context, our project is a software for managing medical centers, and one of its features is providing the ability for the patients to fill in their forms before taking an exam. And we were with the assumption that the medical centers would have a really good internet connection, and we didn't have to worry about request timeouts or initial loading speed. Unfortunately, that was not the case, and these are two of the areas that we needed to improve. When it comes to improving performance, where better to start than the bundle size? And we haven't looked at the bundle size before that, and there were some surprises there yet again. For example, Moment.js, we were using it in a way that it was not reshakable, so it included all of its localized bundles in it. So a quick fix would save us around 20% of the bundle. And another such quick fixes were importing functions from Voldash or RxJS. We could take advantage of the ES modules and import them one by one instead of the whole library. Another improvement that we looked at is the first paint, and there are a couple of approaches there. We could have used server-side rendering, but we weren't concerned with any of the other problems that it solved. For example, we didn't care about SEO, and also we had to think about how to rewrite the server, how to work around browser APIs, and so on. So we went with the ugly manual approach, which was a couple of hundred lines of HTML and CSS in Wind, and that was very quick. It's easy to maintain, and yeah, we went with that approach. another thing that we had to worry, as I said, request timeouts. And here we went with linear backoff. In Angular, there's a thing called an interceptor that stands the middleware between your requests. Here, we took advantage of the request ID that we have in each request that we make. We keep the failed requests, and then every time we retry it, we give it more time to timeout, and that way we can retry a request a couple of times before presenting an error to the user. So that improved the UX a bit. What were the key takeaways for us? Keep an eye on the bundle size. That was a pretty big shock that Moment.js causes problems, because it's a pretty popular npm package. It has around 20 million downloads. Although it's deprecated nowadays, it's still very popular. So we would never expect to have such a problem come from it. And also, hot module replacement is really nice for development, but I think it hides some of the problems, and you see them on production. So yeah, also keep an eye on core web vitals often, and yeah, try to stay diligent and not degrade your performance. Let's move on. We continued growing, and it was the first time that we had a really complicated state management case, and we started thinking about the state management library. So far, what we've used is pretty much the most simple way you can handle state in Angular, kind of the vanilla way, where you have state as the observable, and then you have a behavior subject which you set the state to and read from. This approach is very simple, but it comes with some disadvantages. For example, there is nothing to reuse here. Everybody who does state management does it all over again. The rules are not defined at all. They are not implicit. So the mutability of the state and so on is something that the developer needed to think about and take care of by themselves. However, it's really transparent what's happening. It's fast, and overall, I think it helped the team come to the conclusion of how to properly decide on a state management library. So the options here were Akita and NGRX, the two options that we kind of leaned towards. And we've all have used NGRX and didn't like the boilerplate. We didn't like how the Redux pattern was implemented. So we decided to go with something a lot simpler, Akita. It's not as performant, but we didn't have for example, huge data tables that we needed to take care of or stuff like that. And it played nicely with Angular services, so we decided to go with that approach. What are the key takeaways? I'd say don't rush into shooting yourself with going straight for the most heavy state management library. First, try out what the framework provides, play with it, and when the time comes, go for what your feature requires. We also took a look at micro frontends. At the time they were just becoming popular. They come with some downsides. Unfortunately, you have to think about how different micro frontends would interact, how would they share dependencies, and so on. But they're great if you want to do configurability, extensibility. So we did an RFC on that topic. Another thing that we considered is making our patient-facing app PWA. And at the time, PWA looked like it's going to be the next big thing. Unfortunately, it didn't support some key features on all devices, and I think that even today is it's still lacking a bit. This is something that we investigated, but we didn't implement. There were many other forks on the road, many decisions that we had to make, how to do observability, logging. We had to implement our own design system. I have a talk on that, and I'll soon make an article and a video about it. We also had to research different rendering techniques and so on. That was our journey. Thank you for joining. And as I said, there were many forks on the road, and keeping a Greenfield project green is a continuous job, and it's up to you and your team to do it. And hopefully with the takeaways I gave you today, it would be easier. But still, I think the most important part is not the keeping, but whenever you hit a hidden trap, to go back and reevaluate and make a better decision and go with it. Again, thank you for your time. Check the description for the article, and see you in the next one.